Hi students, Dr. Madewell here. And next, our final lecture is going to be mini lecture 4, descriptive versus inferential statistics. Let me do the slideshow. Okay. We're going to talk about descriptive statistics and analysis, inferential, different types of studies, the importance of correlation not equaling causation. That's a big one. I hope everyone can be able to do well on understanding these so we can build from this information. Once we have our data collected, and this semester you will be downloading archived data that I have collected in the past, and it's a published data set. It's a data set containing data from students from Oklahoma State University, from Southeastern Oklahoma State University, and Cameron University. We'll be using that data for your data analysis quizzes. For your first data analysis quiz, you're going to be using descriptive statistics. And descriptive statistics summarize and organize and describe raw data. So you'll have all this data, and what we'll do for your data analysis quiz 1 is you'll make some charts and some graphs and display your data in a nice, neat way. You'll show means and averages. Okay, that's same term. You'll calculate medians. That's going to be our middlemost score, and our mode, which is the most occurring score. When we're describing data, we'll say how many men, how many women, how many gender nonconforming, how many white, non-Hispanic, etc. We will also talk about the range of those scores. What's the lowest score they could have to a highest score? That would also be a descriptive statistic. If we say, on average, students report studying statistics for 3 hours a week. Well, if we say that, we need to know what's there. Of course, there are probably some students who study 0 hours, right? And then there's probably students that study 20 hours a week. In this course, because it's a 7-week accelerated course, hopefully everybody's studying 20 hours a week. So make sure you get that A. Descriptive statistics are that first preliminary statistic we're going to use to summarize our sample. Descriptive statistics and frequencies describe our sample. They're very important because when we do inferential statistics and we say our data could be generalizable onto maybe people like you, we want to look at the descriptive statistics in an article and say, oh, okay, are there people like me in this study? Does this data relate to me? Super cool, right? Inferential statistics are supposed to draw conclusions about the population based on that sample. Okay, so we have a sample of data. If you are a Native American man, did they have any Native American men in your age range in that sample? So then you could say it relates to you. Maybe yes or no. Okay. We're going to talk about hypothesis testing. We're going to calculate confidence intervals, and we're going to report our p-values. We'll be using SPSS, statistical processing for the social sciences. It's a software package that comes with this class. You'll be downloading it if you haven't already. And that is where we will get our p-values. When we're comparing the two types of data, or a descriptive analysis versus inferential, descriptive is just like it sounds. It's going to describe the sample. Okay, it's going to say the most average score. It's going to describe demographics of the sample. Versus inferential is going to predict from the sample. What our data is telling us about others. Both of these types of statistics work hand in hand, and you're going to be utilizing both of them for data analysis quiz 2 and 3. Okay, if your study is designed well, we could take our sample and generalize our findings onto the greater population. I mentioned this in a previous lecture, but let's go over it in more detail. We have three main types of studies that we do in behavioral sciences. Experimental studies, a true experimental study, is when a researcher manipulates a variable and uses random assignment. Let's look at these two pink rectangles. So let's say you're part of a research team and you want to see what works best to reduce depression in college students. Can we give this new psychotropic drug, or can we have a group that just exercises only? Let's say we have 100 undergraduate students that want to participate in our sample, and we can randomly draw a line in the middle and say, okay, y'all are going over here and we're going to talk to you in this classroom. And then the other group, we're going to take y'all over and show you the gym. And we're going to meet here every day. Da, 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 da. And at the end of maybe 6 weeks, see who has lower depression. Okay, that would be a true experimental condition, and it has that random assignment. Let's look at the second type of experimental study, a quasi-experimental study. That's when we can't randomly assign based on ethics and experience. So maybe we have, let's look at these two green boxes here. Maybe we have a natural disaster group, somebody who's experienced a tornado or some kind of a natural disaster who didn't have childhood trauma. Okay. Then we could compare those people who had childhood trauma, but they didn't have natural disaster. Okay, we could compare those two types of groups. Now, in Oklahoma, where we have lots of natural disasters, we could have a third group where it's a natural disaster and they experience childhood trauma, and we could put those in a combo group. And what we'd want to do is see who has lower depression or maybe higher depression. Quasi-experimental studies are primarily what we do in behavioral sciences. Now, the third type, correlational. Correlational design is when you're just trying to see, are two variables related? Yes or no? We don't know. Okay. If your partner gives you no eye contact, is that related to sexual satisfaction? You know, what's going on? Are these two variables related? There is some research that shows when your partner doesn't give you eye contact, maybe they're interested in somebody else. Okay. Maybe that's what we'd want to study and observe couples and see if they just look at their phone and say, yeah. I love going into restaurants and seeing couples and they're like on a date and they're both just like this. I don't know if they're texting each other or texting others, but it would be quite offensive to me if I sat down with my age range. You know, if I sat down and somebody I looked at the top of their head, I would probably want to leave, right? Well, anyways, when we're looking at correlation, there's no manipulation. If you'll write in your notes, a correlational design is a preliminary analysis. Everybody does correlational, okay? Correlational design, if your variables aren't correlated, you can't do anything else. You got to go back to the drawing board and redesign your study from the beginning. Okay, maybe you picked the wrong sample. Maybe your research criteria was wrong. Maybe you collected data the day there was a tornado coming through town. Okay, so that could be triggering, and maybe you got bad data. But correlational design or correlational studies are kind of like the preliminary type of statistical analysis to ensure that our two variables are related. That means we can go on and do more advanced statistics. This slide would be great for your cheat sheet, to draw this out on your cheat sheet and to make sure it's on your handwritten notes for this week. When we talk about correlation, though, I'm saying how preliminary it is, how simple and basic it is. But when you watch the news, When you listen to podcasts, people often make a huge error. They'll take a correlation between two variables and say it's causal. Okay. Let's say somebody vapes 3 times a day. Well, vaping 3 or more times a day could be related to having respiratory concerns, but it doesn't mean it's causing. Okay, maybe. Or if you eat an apple a day, does that mean you're going to live to be 100 and have no health concerns? We see that having an apple every day is going to, we do see healthier people, but it's not causal. One is not causing the other. A correlation is just looking at as X increases, is Y increasing? X increase Y, X, Y, X, Y. It's not saying causal. We're just looking at the relationship between two variables. We're going to have a whole chapter on this later on. One example is when I love this picture here. It's saying that as ice cream sales increase, so do robberies. As ice cream sales go up, robberies go up. Do you think those two things are related? Write in your notes, your handwritten notes, what could cause, if when people are eating more ice cream, there's more robberies. Why would that be? Well, correlations, because they are so preliminary, we could often see a relationship between two variables, and it's called spurious or a bad finding. There's a third variable that's causing this relationship. That third variable is heat, and we're all experiencing it right now in the heat. We get snappy. Maybe we're not our best self when it's really hot outside. So when we look at this relationship, as ice cream sales increase, we see more robbing happening and muggings and things like that. It's that third party variable is the problem. It's actually the heat. When we're hot, we're going to eat ice cream. When we're hot, we're going to maybe be more of an agitated self and maybe commit a crime. All our criminal justice majors are probably pretty familiar with this. But we want to be careful and understand a basic preliminary analysis. There could be a third variable causing this relationship. We'll talk about this more later. When we put it all together, statistics help us describe our sample, predict outcomes, and explain and interpret this to our reader. And our study type plus measurement level helps us pick a statistic that's correct and have valid results. Okay. This slide would be great for a midterm question to help you pull it all together and say, why do we need to understand a sample, have good research criteria, understand our measurement, and why do we need to do this? Okay, so be thinking about an open-ended essay question that you could answer for this. What's next? So we're done with chapter 1 now. Whoop, whoop. That's awesome. Next, we're going to move on to chapter 2 for the following week. And we're going to talk about central tendency and variability. This is a super fun chapter, but chapter 2 gets intense. We're going to be learning new things that you haven't learned in middle school and high school before. Chapter 1 is a nice quick refresher. It should be like, oh yeah, I remember studying that. If you've ever seen the show, do you think you're smarter than a fifth grader? Man, fifth graders know a lot because maybe it's been a while since we've touched up on some of that stuff. So hopefully this chapter 1 kind of is a refresher for some things that you've seen in the past. If you feel like you are struggling or you are not understanding content, please reach out to me. See me in office hours. Please reach out to Mark, our statistics and APA tutor. Reach out to a friend in class. Anything or somebody who's passed this class in the past. Okay. Study, study, study. Don't wait too late. You have lots of resources available to you, and I'm here to help. Y'all have a great day, and I hope this was a fun lecture series for chapter 1. See you next week.